Hello Dr. Dalila, my name is Daniel Hafiz bin Amal. My matrix number is A25KE5064. We are from Energizer Group and this is our project titled Smart Parking System Integrated with Internet of Things or IoT.
Hello Dr. Dalila, my name is Jason Lee. My matrix number is A25KE5072.
Hi Dr. Lila, my name is Karis bin Nizam and my matrix number is A25KE5108.
Hi Dr. Dalila, my name is Jun Chong. My matrix number is A25KE5022.
Hello doctor, my name is Wan. My matrix number is A25KE0454.
Okay, let's start to our demo video.
Alright.
Hello Dr. Dalila, my name is Jason Lee. My matrix number is A25KE5072 and I will discussing about the problem statement part. First of all, parking in Malaysian city is a major challenge that reduces urban efficiency. One key issue is traffic jams. Because drivers spend too much time searching for a parking place, which causes traffic jam in a busy area. Another problem is increased carbon emission. Vehicles idling while looking for parking cause burn more fuel and release more carbon dioxide, and it will harm environment and cause many pollution too. This is also a lack of real-time parking information, so driver cannot check ability in advance, leading to unnecessary driving. This situation wastes both time and fuel, as drivers spend extra time and resources searching for parking. Finally, many parking areas still rely on manual management, while it's slow, inaccurate, and prone to errors.
Hello Dr. Dalila, my name is Daniel Hafiz bin Amal. My matrix number is A25KE5064 and this is our project. This is a smart parking system integrated with the Internet of Things or IoT. So in our project, it is consists of two IR sensors to detect the presence of the car, an LCD screen with the I2C technology to display the available parking spot, and inside this powerhouse, we have our board integrated, all the wiring, and most importantly, the ESP32 with the built-in Wi-Fi module. And not to forget that we also have a servo motor to act as a gate whenever the parking is full.
Hello Doctor, my name is Karis bin Nizam and my matrix number is A25KE5108. And today, I'm going to demonstrate you how the IoT works in this project. So, first of all, as we can see that the LCD screen display 2 out of 2, which is both is empty. So it also update on the Blink app. The parking slot 1 and parking slot 2 is empty and the available parking is 2. So whenever the car going inside the parking slot 1, it will update on the LCD screen and also it will update on the Blink app. And whenever there is 2 car going inside the slot, it will also update both of them, and also it will indicate the gate so that the gate will shut, the gate will close and there is no one can enter it, so we can avoid a traffic jam inside the area. So whenever there is a car going out or going out from the parking slot, it will update the LCD and the blink so that it will show empty, so that the car can go in and go park their car inside it. So whenever there is a free parking, so the other car can go and park inside it.
Three. Two. Okay. Hello Dr. Dalila, it's me again, and this time I will try to introduce our group flow chart. The system logic begins by initializing the hardware and establishing connection to Wi-Fi in the Blink card. Once active, it continuously monitors the two IR sensors to detect vehicle movement and calculate real-time occupancy based on the two slot capacity. If the available slot reaches 0, the system automatically closes the servo gate and updates both local LCD and the Blink app to display full status. Otherwise, the gap remains open and the status display as available. Every circle concludes by syncing this data to the cloud and the local display before looping back to the sensors to ensure the system remains constantly updated.
Hello, my name is Daniel Hafiz bin Hamal. My matrix number is A25KE5064, and today I'm going to present about our circuit diagram in detail. So let's break down our component first. We have two IR sensor, 16x2 segment display with the I2C technology, ESP32, and finally the servo. So in this diagram, we are using a breadboard as a medium to connect all the components together. At the initial stage, the diagram is designed using FreakZing software. So troubleshooting the wiring will not cost anything, as our early stage development is done by simulation, ensuring efficiency when it comes to real installation. So let's break down our component first. We have the IR sensor module. IR sensor module is an electronic device used to detect obstacles or measure a distance. So in order to either detect obstacles or measure a distance, we have to first configure the pin mode when it is connected to the ESP32. Typically, there is analog and there is a digital mode. Typical analog range between 0 to 1023, while digital only read a binary value of 0 and 1. In this case, we only want to detect the presence of car, so we are going to use a digital value, which means that 0 doesn't detect and 1 detect. It will be much easier to use digital compared to analog, because analog tends to use a lot of time to configure its value using its potentiometer right here. There are two LED that correspond to the emitter and receiver. An emitter emits the light and the receiver will receive the light. So in the case of analog sensor, it will measure by subtracting the value which the light goes and with the distance when the light is received. So these two values when being subtracted is the distance traveled, which will be converted by the ADC module inside this ESP32. And next we are going to talk about 16x2 I2C segment display right here. So 16x2 LCD display is an electronic module used to display text. Standard generally doesn't include inter-integrated circuit, which is the full form of I2C, which requires 6 to 10 digital pins. As you can see right here, if the LCD display only require 4 pin, meaning that it have a built-in I2C technology. So what is the differences between I2C and the standard LCD display? Typical standard LCD display have a lot of pin, which require much more pin to connect it to the ESP32. But with I2C technology, we only require 4 pin, which stand for VCC, the ground, SDIO, and SD clock. So the main difference between the standard one and the I2C one is that the standard one typically use parallel line transfer data, which means that the data is traveled simultaneously into the LCD display. However, with the I2C technology, it is transferred only with one line data. One line data means that the data is transferred MSB to LSB. That is the main differences. And next we have ESP32. So ESP32 is the most popular, a low cost and power efficient microcontroller, and has an integrated Wi-Fi module, which is crucial for the Internet of Things. You can see the built-in Wi-Fi module right here. Compared to Arduino generally need to use Wi-Fi shield, which will add more cost to our project. So we decide to use ESP32 as a better alternative compared to Arduino IDE. Here, as you can see, the long line here is actually a GPIO, or we call it as general purpose pin input and output. It consists of analog and digital, which must be carefully examined before using it. Like an example of using the Arduino, using the ESP32 with IR sensor. So we can either plug the signal pin of the IR sensor to analog pin of ESP32 or digital pin of ESP32. The operating voltage of ESP32 is typically 5 volt and will be regulated to 3.3. Meaning that if we plug into the laptop typically will output 5 volts, and the processor inside it will process 3.3 and distribute it evenly to our GPIO right here. Next, we have the servo motor. Typically, we use SG90 micro servo. SG90 micro servo is much cheaper compared to the standard servo. It is a lightweight servo which must be cheaper, and it is designed to move between 0 to 180 degrees. The main use of this servo is for our gate. It requires 3 pins, which is a VCC, ground, and the pulse width modulation, or we call it as PWM, which is basically a signal to tell the servo how much we want to move between 0 and 180 degrees. The typical voltage required to operate the servo is much higher because it is motor, and motor currently tend to pull much more current compared to other components. The typical range is 4.8 to 6 volt.
However, ESP62 only provide 3.3 ADGPIO. Luckily, there is one of the pin that will share 5 volts when we plug in the power supply of 5 volts. So, the servo motor power VCC will connect it to the pin which has a 5 volt. The torque of the motor is lower because servo motor is only for the mini project, typically of 1.8 kg per centimeter, meaning that 1 centimeter, the servo has the capabilities to lift 1.8 kg, which means that the material that the servo can lift must be lightweight material. So that's all from me. Thank you.
Hi Dr. Dalila, my name is Bujin Chong. My metric number is A25KE5023. Our project is a smart parking system with Internet of Things, designed to support the United Nations Sustainable Development Goals. First, this project supports SDG 11, which is Sustainable Cities and Communities. When the parking area is full, the system closes the gate automatically so cars cannot enter. This helps reduce traffic congestions and improve parking management in cities. Second, the project supports SDG 7, which is affordable and clean energy. By stopping cars from entering a full parking area, the system reduces unnecessary driving. This helps save fuel and reduce energy waste. This project supports SDG 9, which is Industry, Innovation and Infrastructure. The system uses IoT sensor and automatic gate control, which shows the use of modern technology and smart infrastructure. Overall, this project shows how simple technology can help create smarter and more sustainable cities. Next, I will pass it to Jason to present the flowchart part.
For conclusion, the smart parking system is not just about the parking much more smarter, since we also integrated with the IoT, meaning that we try to approach the SDG 11, or we call it as a sustainable cities and communities, which focus on making the cities much more inclusive, safer and reliable for all communities to use.
Thank you.
Hello Doctor, that's all of our final project. I'm the editor Jason. Thank you for watching our video.